Hello and welcome to the Math 1 Prep Club. My name is Mr. Herb and I'll have these videos for you in case you miss a synchronous session. These videos will help you review and even come back in case you had a question from that day's lesson. What I'd like you to do right now is pause the video and try out these 4 problems. Alright, so let's get to solving them. The first thing we need to do is isolate this 3x. So I'm going to subtract 4 by each side, so that way I can get 3x plus 0. This gives me 3x is equal to 6. And then I divide by 3 because to undo multiplying by 3, we divide by 3. They're kind of like opposite operations. This gets me x is equal to 2. For this second one, I can either distribute the 2 to everything inside, so to the x and the 5, or I can just start off by dividing by 2. I like that step just because it makes it one step fewer that I have to deal with. This gives me x plus 5 is equal to 6, so now I subtract by 5 on both sides and get x is equal to 1. If I want to check my answer, I could plug that back into the original equation, and I would get 2 times 6, which is 12. So that checks out. For the third one, I would first start by subtracting 4. We need to be careful of this one because we need to make sure we keep that sign of a negative 2x. So negative 2x equals 8. And then now when we're dividing both sides by negative 2 to isolate the x and get x with a coefficient of 1, we get x is equal to negative 4. Remember that a positive number divided by a negative number will end up giving us a negative number. The same thing works with multiplication. A positive number times a negative number will also give us a negative. And the fourth and final one. I'm going to first subtract 5 from both sides, and this gets me 2x is equal to 3. Then I divide by 2 and get x is 3 halves. I like to leave this as an improper fraction. If you'd like, you could write this as x equals 1.5, but try to avoid for now dealing with mixed numbers. We're going to try to keep everything as an improper or a decimal. All right, so let's talk about what we have going on here. So here's kind of the rules for Math 1 Prep Club. You got to remember, guys, that this is going to be challenging. Remember that we are going to be trying to learn enough to skip multiple grades of math. So understand that this is going to take some effort and some work. Sometimes we might need to rewatch videos, but the biggest thing we need to do is ask all of the questions. No question is too small or too big to be answered, so always feel free to reach out, send me an email, or just ask a question in the comments, whatever you want to do. The other thing, I expect you to do all the problems that we put forth, so kind of keep that in mind as well. So we're going to start by solving some equations with variables on both sides. The problem with this is that we can't solve for just x equals without getting it in terms of some other x. For example, if I tried to subtract 12 here and got 3x minus 4 is equal to x, well, that doesn't really solve my answer. I can't say x is equal to 3x minus 4 because that's still not in terms of just one x. So the first thing we're going to do is get all of our x's to one side. We want to get all of our x's to the side where more x's exist. So for example, if I look at 3x and x, I would say that there are more x's on the left-hand side. So I'm going to subtract x from both sides. This gives me 2x plus 8 is equal to 12. Next, I subtract 8 from both sides and get 2x is equal to 4. From there, we do the opposite operation of multiplication, which is division, and we're going to divide both sides by 2. This gives me x is equal to 2. And again, we could plug that in and check. 12 plus 2 equals 6 plus 8. Yep, that will work. 14 is 14. For the second one, I have a whole fraction to deal with. So we have a couple options that we can kind of use to help us solve this one. We could multiply out the 2/3 and get a 2/3 x plus 14/3. That's something that's possible for us to do, but sometimes leads to a little bit of a messier answer. Instead, we can kind of write this as 2 times x plus 7 over 3 equals 4x plus 5. This is still times the 2/3, but writing it in this way makes it a little bit easier for me to deal with. For example, now I can just multiply both sides by 3 to undo the division of 3. Then I'll start to distribute my numbers. Well, this 3 over 3 will reduce down to 1, and we'll get a 2x plus 14 here. On the other hand, we're going to have a 12x plus 15, and so now this problem looks a little bit like the one we just dealt with. This gives me a 10x plus 15 by subtracting 2x from both sides equals 14. Next, I subtract 15 from both sides and get negative 1 equals 10x. Finally, we divide by the coefficient of x. In this case, it's 10, and we get x is equal to negative 1/10. Again, that's one way we could have solved this problem. We could have done the exact same thing, but instead of doing all of this, we could have just distributed the 2/3. Let's look at what that would look like. That gives me a 2/3 x plus 14 over 3 equals 4x plus 5. Now, 4x and 5 aren't really great numbers to deal with when we're dealing with a 2/3 and a 14/3. So instead, I'm going to change the 4 to a common denominator with 13. We're going to change this to be 12/13 x, or sorry, 12/3 x, because 12 over 3 is just 4. And then we're going to change this to 15 over 3, because 5 is just 15 over 3. Now we would subtract 2/3 x from both sides. And this gets us 10/3 x plus 15 over 3 equals 14 over 3. Then we subtract 15 over 3 from both sides, which gives us a negative 1/3 equals 10 over 3x. Now we multiply by the reciprocal of 10/3, which is 3/10, and we're going to do that to both sides. Doing it on the right-hand side just gives me 1x. Doing it on the left-hand side gives me a negative 3 over 30, which simplifies down to negative 1/10. So either way we did this, we got the same answer. The first way deals with less fractions, whereas this way we kind of have to deal with these improper fractions the entire time. Both ways work though. What I would like you to do is pause the video here and try this out. If you got x equals 5, you can move on to the next problem. If not, stick around while I explain. The first thing I would do is distribute the 2 to both parts of the parentheses. So this would give us 2 times 5x and 2 times negative 1, which gives us 10x minus 2. For the second one, we distribute the 3 to everything inside. That gives us a 3x plus 33. Next, I would check where do I have more x's. In this case, it's the left-hand side. So I'm going to subtract 3x from both sides to get that down to 7x. So 7x minus 2 is equal to 33. We're then going to add 2 to both sides and get 7x equals 35. Our final step is dividing by 7, the coefficient of x, and that gives me x equals 5. Again, as always, we could plug that in and check to see if it works, and it does. Pause the video and try out these 4 problems. I'll reveal the answer and then explain what the solutions mean. All right, so this is what we got for each one. This first one, I'd distribute the 4 to everything inside, and I'd also distribute the 2. I subtract the 2y over. I'm going to write this down here. 6y plus 4 is equal to negative 26. Subtract 4 from both sides and get 6y is equal to negative 30. And so y is equal to negative 5. And again, if you guys got these ones correct, feel free to move on. For b, I do a similar thing. I get 28 minus 7a equals 3a minus 12. This time I'm going to add the 7a over, so that way I can still have positive a's. This gives me 28 equals 10a minus 12. And now I add 12 to both sides to get 40 equals 10a. So then a equals 4. In C, I have to distribute this negative. This may be one that trips up a lot of people. This gives me negative 8x minus 3x minus 6. equals 4 minus x. Then I combine those to get negative 11x minus 6 equals 4 minus x. Next, I'm going to add 11x to both sides because negative 11 is essentially more to the left of 0 than negative 1. This gives me negative 6 equals 4 plus 10x. And we can see that, again, we're dealing with a whole bunch of negatives here. I'm going to subtract 4 from both sides and get 10x equals negative 10. Finally, dividing by 10 gives me x is negative 1. All right, final question with D. We're going to distribute this negative 3. That gives me a negative 3n plus 12, because a negative times a negative is a positive. And then again, don't forget that 8n. Let's simplify that right-hand side to get 5n plus 12 equals 3n plus 14. Next, I see I have more n's on the right-hand side, so I'm going to subtract 3n from both sides. This gets me 2n plus 12 equals 14. So 2n equals 2 by subtracting 12 from both sides. At this point, I need 1n, not 2n, so I divide both sides by 2 and get n is 1. And that's our final answer. Wow, look at this one. So many steps. Let's go for it. The first thing we want to do is always distribute the coefficient in front. This 3 stands alone. We can't combine these two due to order of operations. Order of operations says deal with parentheses, exponents, multiplication, and division before adding and subtracting. So let's distribute out this negative 2. So negative 2x minus 14, and then we have a 3 there. On the right-hand side, I have 6 times 4 is 24. 6 times negative 2x is negative 12x, and then plus 10x. Let's simplify our left-hand side first. The only thing I can combine is the 3 and the negative 14. This gives me negative 11. I'm going to put the x in front just so that way just the normal way we would write these equations and expressions. On the right-hand side, I can combine a negative 12x and a 10x to get negative 2x. Uh-oh, I think we're seeing a pattern here. What's going on? If we look at this, we have negative 2x minus 11 equals negative 2x plus 24. If we add 2x to both sides, we get negative 11 equals 24. Oh no. I think we can both agree that negative 11 is not equal to 24. This would be no solutions. Now, it's always good for us to check, make sure we did the problem correctly. But in this case, we could do this as many times as we want. We're still going to have our x's cancel out. So this is no solutions because there's no value for x that will make this work. In fact, this shouldn't even say equals. It should be scribbled out. These two things are not equal. What we just looked at is something called an identity. Or not an identity. This is an example of a no solutions. If we have essentially an expression equal the same expression, that's known as an identity. If we have an equation equal essentially the same equation, but your constants are off, right? 1 is not equal to 2. This gives an example of a no solution. Let's check this one out. Try these two. See if you can figure out, is it an identity, which is also another way of saying infinite solutions, or all real numbers. Let's say all real. Or is it no solutions? Pause the video and try it out for yourself. For the first one, I get all real numbers. This is an identity for sure. Multiplying out that 3 gives us 12b minus 6 equals negative 6 plus 12b. And those two are equivalent. For the second one, I get no solution. If we multiply out that -1, we get -3 plus 2x is equal to 2x plus 7. Well, those constants aren't the same, even though the variables are, right? We both have a 2x and a 2x, but one has a -3 and one has a 7. That's a no solution. Okay, try these two problems out. When you're done, or pause the video, and when you're done, come back to see the solutions. For the first one, I got infinite solutions, or all real numbers, meaning x could be anything and it would work. And for the second one, I got no solutions. If we distribute out this 3/4, we get 3x plus 6 equals 3x plus 6. 3x and 3x are equal, but more importantly, so is the 6 and the 6. In the second one, when I distribute out the negative, I get a -4 plus 2x. When we combine the 5 minus 4, this gives us 2x plus 1. And the other one is 2x plus 10. 2x is congruent to 2x, but 10 is not equal to 1, and therefore no solutions. If you need extra practice, check out this second one, but if not, continue on. Or third one, I guess. This third one would also be no solutions, because we get 6x plus 20 equals 10 plus 6x. If we subtract over the 6x, we get 20 equals 10, and that's not correct. All right, last two, let's try to look at some word problems, specifically talking about perimeter of a rectangle. Now, we should know that the perimeter of a rectangle is equal to twice the length plus twice the width. We can kind of draw a picture for ourselves and get length plus width plus width. Now we know that 50 is equal to 2L plus 2W. We're also told that the width of the rectangle is 4 more than twice the length. So the width is 4 more plus 4, twice the length, 2 times L. If we were to draw a picture, this would look like 2L plus 4, 2L plus 4, and then L and L. Notice this is definitely not drawn to scale. If we add all of these up, 2L plus L plus L plus 2L, we get 6L, and then the 4 plus 4 gives us 8. So 6L plus 8 equals 50. This gives us 6L is equal to 42 by subtracting 8 from both sides. Or L is 7. Well, wait, we found the length. It's asking for the width. We need to plug that back in. The width is equal to twice the length plus 4, which gives us 18. So our final answer, the width is 18 inches. And we could check that out. 18 plus 7 plus 18 plus 7, well, that adds up to 50. All right, last problem. And we're going to spend more time on these kinds of word problems. But we're going to talk about angles of a triangle. So a triangle has two angles. The second angle is twice the first. The third angle is 2 less than half the first. Well, first of all, I need to know what the angles of a triangle add up to. The angle sum of a triangle equals 180 degrees. Secondly, a triangle's second angle is twice the first. Well, I don't know what the first is. Let's call that x. So if x is the first angle, the second angle would be 2x. And the third angle is 2 less than half the first, 1/2 x minus 2. Now, let's add those all up. 2x plus 1/2 x minus 2. That's going to all add up to 180. Now, this will give me 3.5x minus 2 equals 180. I'll add 2 to both sides. and get 3.5x equals 182. Next, we divide by the coefficient, and 182 divided by 3.5 gives us x is 52. Now, that's one angle, but we want all of them. So the first angle is 52. The second angle is 104. Again, degrees, degrees. And then the third angle would be 24. We can check those all up and realize that, yeah, those all add up to 180. Now, if you thought the last two problems were much harder than the other two, or the whole rest of the lesson, I 100% agree. We're going to get more into word problems later, but I wanted to give you guys just a taste of this lesson. If you have any questions, please feel free to reach out. Otherwise, have a great day. Bye.